I'm Christopher, Design Computation Director at KieranTimberlake. Around 100 architects, landscape architects, sculptors, graphic designers, urban ecologists, environmental managers here in Philadelphia. And today I wanted to talk about how we've integrated Vue into our design practice. I won't dive into the benefits of Vue. Those have been eloquently described by previous contributors here, but I do want to frame the many additional questions that arise once we dive in. Beginning with, what are we asking and why? Are we asking how much can we see from site to building, from building to site, so inside out or outside in, for how long and how is that mitigated? Once we start framing that, like what can we see? What do we want to see? So how do we start assigning value to the context around us? And once we have that value, cumulatively, what is the quality of a view? And once we start thinking about multiple views, what is the equity of view across a particular design? And so once we have all of these different questions, immediately we're starting to ask, when can we ask them, and when can we kind of dive into this? What kind of substrate do we need? Is it just a kind of a blank site? Do we need a massing, a facade? Are we thinking about floor plates? And based on these kinds of decisions, how much can we be sure of our answer? How accurate is our context model? What are the trade-offs of our calculation methods? Be it the analysis substrate, how we sample, how we project, as you've all heard today. And then finally, based off of this kind of cumulative stacking of questions upon questions, how do we actually communicate our results, our assumptions, the caveats, to people who essentially speak the same language within the research group, within design teams towards design decisions, and maybe even clients. So we'll be looking at these questions as we give a short history of our attempts at quantifying view through the lenses of kind of extent, access, content, and clarity. Most likely ordered in relation to the level of detail required to start answering that question, the design questions that may arise based on phase, and ultimately maybe the level of difficulty to simulate or understand. So early on, we try to understand our starting condition. Rough look at viewshed, maybe modified only by surrounding context. And so this kind of idea of extent, maybe even before access, so not modified by any kind of architectural decision just yet, other than those that surround you. We try to leverage isovists and isovis fields, or kind of accumulations of multiple isovists, to understand corollary metrics of view extent and detail, kind of proxied by the isovist area and the perimeter, so understanding those things. And in the earliest questions, as others have mentioned, context is just as important as any tool. So we always confirm our analysis with using the older version, excited to use the new studio version here, of Google Earth's simple viewshed tool, looking at view across elevation and corners of sites. So we always confirm this with site walks and photography as well. In terms of our early studies of window view access, we leveraged similar techniques to those isovists that were really focused on the automation of previously manual credentialing workflows. So LEED 2009 required us to achieve a direct line of sight to outdoor environment via vision glazing for 90% of the regularly occupied floor areas. So we really took those kind of similar concepts in a 2D manner almost, and struck rays from the edge of windows to kind of back to the kind of corners of rooms to understand general area of room that had a view to the outdoors. So this analysis really relied on a collage of methods to fully qualify, and was really tightly coupled to this eventual deliverable you can see on the left from the kind of green building design and construction reference guide. And this really, while meeting the kind of requirements, limited some of the questions we could ask beyond credentialing post-design. So we're interested in understanding more about views and earlier. This desire to better understand the nuances of view got a nice little push from the move from 2009 to 4.0, where daylight in view became quality view. So adding an emphasis on the content of view by making those kind of previously exemplary metrics part of standard practice. A series of technical developments regarding the what and the how kind of made these answering these questions around types of content feasible. So tools for downloading metadata-rich kind of context of our sites allowed us to rapidly describe the buildings and sometimes vegetation and streetscape around us. The increase in the cores of our CPU and GPUs benefited the inherently parallel kind of process of raycasting. And so we've come to this point where ourselves, with our custom Grasshopper scripts and others, as you've already heard in Symposium, have developed techniques to understand essentially the additional list here between one, the kind of the relationship between multiple views, two, the kind of the content of views to some degree, the relationship to glazing, three, and kind of to a limited degree, as you've heard before, this idea of view factor. So our tool allows us to cast rays from a 360-degree horizontal, 60-degree vertical view field. And we basically use the percentage of hits as a proxy for that solid angle that Brendan mentioned for view content. I think the caveats are whether that content that you're seeing across this larger range is actually contiguous or widely distributed. And that's something we haven't just tackled just yet, but I think is another opportunity for discussion. In terms of the finely granular or distributed content in these view fields, how our context is modeled is filled with kind of reductive assumptions, in particular how we kind of characterize vegetation, ground density, seasonal change, and those also offer a good deal of opportunity for improvement. So as our abilities to not only model urban scale context, but automatically assign identity metadata to that context grew, we began to analyze the content of our views. And patient view was a particular interest due to their relatively stationary nature and lack of agency for different break or primary views when compared to typical building occupants. We not only wanted to understand the content of the view, but how that scaled across multiple floors of a tower. So cut sheets for view content and depth were grouped by cardinal direction and automatically generated to enable a kind of quick scanning of potential massing or shading implications. So here on the left, you see the cut sheet. On the right, you see an identity map for a few select buildings, the Comcast Center and One Liberty Place in the background, as well as the depth of all those individual pieces with some louvers casting kind of a black pattern on the upper image and red on the depth image. So the static nature of patient bed view meant that these kind of subtle adjustments to vertical shading devices could have a significant impact on view. And there was discussion about vertical fins to the east and west, and we wanted to make sure that that impact of perpendicular shading devices to a view were part of the conversation. So we were using this tool to quickly sketch, across the entire facade of a building, perpendicular, basically fins perpendicular to the glazing, fins starting to orient towards proposed patient bed layouts, as well as ones that tried to negotiate caregiver and patient views. So the further we dove into the occupant experience, the deceivingly straightforward idea of a stationary view really produced more questions than answers. There were kind of questions about assumptions we made in terms of what was an appropriate central field of vision, what you can see in that, how do we account for movement of the eye, of the neck, flexion, extension, and rotation. And moreover, even within a stationary patient bed, there were multiple resting positions. So how do we account for the fact that, again, this is not simply a point in space, but a body that is dealing with ailments and a bed. So not only did we face these assumptions about the body's relation to space, our methods for simulating also prompted a dive into our assumptions on analysis substrate, sampling resolution, and context detail. So here on the left, you see the difference of an urban view, the difference between a fraction of a second simulation and multiple minutes. So buildings disappear, content is lost, accuracy definitely is as well. So understanding sampling in relation to not only the complexity of the view beyond, but the complexity of the space within is pretty critical. You can also see that on the shaded view in the center of the frame. So while we were contending with our assumptions, we were also grappling with maybe the conflicting desire to ask them these questions even earlier. So we wanted to know, like, how could we work our way in from an ideal potential at the massing envelope? And critical to any approach that, and we do this with every project, is starting to break down what we value. We've heard from many kind of baselines in terms of stratification of view, particular items of interest, but we always like to talk about this kind of content because once we understand our values, we can start to understand how maybe productive frictions might emerge. So here we used a similar ray casting approach, but actually used it on the facade, almost like the ideal view at the facade out. And we wanted to try to use this to guide interior programming. So in a small residence, we found that the content of this kind of ray casting can be filtered by any object. So we can understand this ideal potential views mapped across this massing. And while we built this tool to allow for multiple weights of content, we typically avoided the urge to reduce view to a single fitness variable early on. And instead, we kind of leveraged these false colors and annotations to map opportunities or challenges. So those productive frictions that I described really can be found within just even the content of facade view when you think about the fact that windows are typically a two-way street. So pitting the privacy views of the windows and sidewalk versus a desire for views to nearby trees or long views of the water. So we're currently testing how these kind of ideas of view quality and content can be in deeper discussion with a wide array of performance metrics. On a recent institutional project, this begins again with a discussion of content and value. In this case, there was a desire for long views with stratification of water and sky, of immediate views of the trees, and an aim to ultimately avoid the mechanical afterthoughts of the surrounding roofscapes that you see here in pink. And once we had this kind of context built and identity assigned, we could start to ask questions of content, but early phase work begged a whole additional series of questions of substrate. So what are we beginning with? Is it this facade? Is the massing starting condition that we're going to use a max buildable? Does it include ideas of a scheme or an approach to site? Do we include future context? How much can we be sure of future build out scenarios? And ultimately, how do we start to carve this for view? And so once we started to carve this kind of massing, we aim to kind of continuously layer and juxtapose desires, metrics, and systems using the massing as a point of discussion across project goals. So we looked at acoustic desires, glare, daylight, window to wall, possible window to wall ratio mappings, social interaction, access, structure, scale, course views, transparency, the nearby context character, and interior program. So that even though we're kind of looking at view quantitatively, we're always actively checking it, annotating it based on site photography, Google Earth, and model views, as well as looking for these particular opportunities, areas where we could start to kind of puncture the envelope, and ultimately how they relate to other factors. So we dive into factors that directly affect views, such as glare and daylight, but also decisions that these apertures that we're proposing would alter, such as desires for acoustic sensitivity, a program, or energy, again, with these kind of rough window to wall ratio budgets that we prescribe. So we've developed tools that allow us to essentially sketch on the facade and have these heads up displays to be in dialogue, but then also use these in design reviews to really kind of focus the discussions, not just with metrics, but with goals. So you'll see that, again, the interspersing of analysis in terms of model derived versus goals of program kind of interspersed. In terms of the final lens of clarity, we've tended to start from the outside in and focused on physical prototypes over digital simulations. So with many of the projects, we often have competing desires for a high level of transparency and performance. So in the past, we've leveraged essentially this custom glazing evaluation apparatus to compare the clarity and transparency of 9 low-E coated glazing samples. And really what we're trying to achieve here with a admittedly small sample size of 8 and 5 over the 2 evaluations is making sure that this is outside under a variety of sky conditions in the same orientation of the building site, simulating actual view angles experienced on site, and cross-referencing with a scaled model placed behind the glass to sample interior conditions. And this is continued with a shadow box color study, again, looking at how we can architecturally detail to reduce the performance-driven glass coating tint, as well as Frit studies looking from the inside out, using our own office kind of as substrate for looking at Frit across multiple times of day, cloud conditions, Frit patterns, and dot densities. And we're always attempting to acknowledge this idea that it is a two-way dialogue, so what we can see from the outside and what we can see from the inside, and really trying to find those edge conditions and building those out as far as space and material will allow. And finally, we try to have fun with this. We've been continually exploring ways to augment our realities to understand the kind of multiple overlays. In this case, an AR app, Holy Frit, that attempted to quickly kind of sketch out Frit patterns across a glazing. And finally, in summary, like most early research, we've developed more questions and answers. We're extremely excited to see this current research and are looking forward to seeing more, especially regarding biological and physiological aspects of view, user survey-driven results, and a wider discussion in terms of moments for analysis and intervention and sharing of the code that we write, as well as comments on standardization. And again, I want to thank everyone that was involved in all of these studies, as you can see here. Thanks.